Hello, everyone, and welcome back to Build. I am Jeff Holland, Principal Program Manager for Azure Serverless. I'm really excited to be able to have this session with all of you today, whatever time of day it might be for you, talking about building, integrating, and scaling with event-driven apps. Now, I introduced myself, Jeff, but I'm actually pleased to be joined with two very special guests. We have Anthony Chu, who's going to be here helping answering questions, keeping an eye on chat. We also have Clemens Vasters, who's the principal architect for all of messaging across all of Azure. And so as we go throughout this presentation, if you have questions, things you want to learn more about, I'm going to save a ton of time at the end to go over those questions. So keep those coming in the chat window, and we'll get to them in just a few moments. Now, as for this session, we've got a jam-packed agenda. We don't have the full day, so we're going to jump right into it, talking about event-driven apps. So I want to cover here, and I'll move this out of the screen. I want to cover here, what are event-driven apps? What does that word even mean? Why would I care about it? How could I use it? And then I'm actually going to walk through leveraging technology in Azure to build an event-driven app, starting with events, putting it inside of a workflow, calling some functions, integrating with APIs, and then as I mentioned at the beginning, we're going to have tons of time for Q&A. So let's start with that first part. What is event-driven? And this is a huge term. It's a very important term. It's a term that's been around for a very long time. But for the sake of this presentation, I want to try to simplify it. As exciting as it is and as many benefits as it might bring, let's just keep it pretty simple for now. And that's that, think about your business, think about your own personal life. There are events, there are things that are happening. Something happens and you want to do something as a result. And so when we think about event-driven apps, you're often thinking, okay, something happened. I want to be notified so that maybe I can run a little bit of code, or maybe that event means that I need to notify some people in a Microsoft Teams channel. Maybe it's actually going to start kicking off a bit of a process. And so those events could be anything. This doesn't need to be restricted. You don't need to overcomplicate it. An event might be, it's 4 o'clock on Friday, and so I need to go process all of the time cards for employees of that week. Or a new customer has joined. That's an event that I care about, that some systems might care about that notification. Maybe the event's coming from an IoT device. Somebody's entered a room, the temperature in this room has increased or decreased, and as a result, I want to be able to do some computation, do some thinking around what I should do because of that event. Or a very simple world, like very generic, it might be an HTTP request. An event is somebody's coming to my website, somebody's visited here, they're clicking around, and events are happening every time they're clicking on different components that maybe I want to act in response to. So when you're building event-driven apps, you're really creating and crafting your code in a way so that you're responding directly to those events. That's kind of the source that you're building off of. And event-driven brings a bunch of benefits. Some of the biggest ones is that when you build applications this way, just by nature, it becomes easier to be very loosely coupled. So if you think about one of these events in this example list, a customer has joined. Maybe for now you want to notify your marketing system, but then 2 weeks down the line, you're like, oh, we actually have this new CRM system that cares about it too. I don't have to go crack open a bunch of pieces. I just add a new subscriber to that event. All of these are very loosely coupled with each other. I can add, remove, keep them highly composable, very loosely coupled, keeping me agile. Really, that's the benefit here, is I'm moving or adding or changing capabilities. I have full agility to do what's best for me at the time. And another huge benefit, especially when you pair event-driven with serverless compute options, are the cost and utilization benefits that you get. So think about an event like somebody visits a website. And imagine that I have some code that I want to run whenever somebody visits my website. Well, if I build this in an event-driven way and host it in something like a serverless function to say, run this code when someone visits my website, but nobody visits my website. They don't care. They're like, Jeff, your website's boring. I'm not going to go to it. That's okay, because no events are happening. And by effect of that, no functions are ever running. And I'm not even charged. With serverless compute, you only pay for the compute that you're utilizing. And so my bill would be nothing because no events are happening. But on the inverse, maybe my website is amazing. I post an incredible blog post and people just want more. So they keep coming. Millions of events are firing. I can spin up million instances of that code to run in response to those events, keeping my utilization closely coupled to the actual event that's driving that work to begin with. So those are some of the benefits and reasons that folks look at event-driven apps and try to figure out how they can bring those benefits into apps that you might be building. So if we think about Azure specifically, there's a few key services that I want to highlight here for the rest of my presentation around these serverless event-driven applications. So I've mentioned one a few times already, that's Azure Functions. This provides event-driven code that you could write in C#, Python, Java, JavaScript, really any language. Logic apps that provides workflows that can integrate with hundreds of different systems. EventGrid is an event broker. So you can think of this as an event like a new customer is added, lands on EventGrid. An EventGrid can route it and make sure that all of the interested parties, people who care about a specific subtype of that event, can be notified, all connected and notified through EventGrid. And then API management acts as a central spot to organize and manage all of your APIs, all of those endpoints, including functions, in a central spot, giving you also the flexibility to set things like policies, to be able to say, hey, I only want to let somebody call this API 100 times every minute, and after that, start blocking additional requests. All of that can be configured with API management. So a very useful tool to have here too. Now, this isn't inclusive. There's a whole bunch more here that you're probably going to end up using pieces of as you build a full-fledged solution. That includes things like event streaming with event hubs, data with Cosmos DB, application monitoring, DevOps, service bus messaging, you name it. These are all pieces that to be aware of as well, and thinking, you don't have to just work within the small box, but dig into functionality and benefits throughout the entire Azure cloud that can help you build better applications. And then something I always like to spend some time highlighting is the developer experience you get as well. I feel like one of the reasons I'm hearing more about event-driven lately is because the development experience around it has had some incredible boosts when it comes to things like serverless. And so it's easier than ever to write these event-driven applications, host them in the cloud, and have them scale. And we make that even better with stuff like Visual Studio Code, GitHub, Visual Studio integration, so that you're using those tools, those languages that you love, but getting these benefits that event-driven can provide. So kind of a high level, hopefully if some of this was new to you, it's a very basic overview, but that's how you can start to think about where some of these pieces might fit in. To make it more real, I actually want to walk you through this right now and show you a little piece of each of those components. And we're going to do a pretty simple scenario. Let's go back to that kind of website example. Imagine now that I've created a startup. This is my wonderful, beautiful idea, the next billion-dollar business. And so I've gone ahead and published a website, maybe published an app. And now I want to write an app, an event-driven app, that can do some work whenever somebody new signs up for my app on my website. So anytime, that's the event, anytime someone signs up, go do a bunch of stuff. So let's walk through that now. Where I'm going to start is actually here in the Azure portal, surprise, surprise. And because I'm thinking about that event, right? Like a user is signing up. My first place I'm going to start looking is going to be EventGrid to get those notifications where I need them to go. Now, EventGrid is great because it integrates with a number of event sources like Azure Resource Groups or Azure Storage or Azure IoT to instantly be able to reload those events for me. I could also publish my own custom application events to EventGrid. But I want to also showcase something brand new that we've just announced this week called EventGrid Partner Topics. This enables any partner to start publishing their events that can now be relayed to my applications in Azure all through EventGrid. So in this case, my application for my startup is using Auth0. So I have Auth0 over here. I've just got a default application. But because of this new partner topic functionality, I can actually come over here and right within Auth0 say, hey, send some of these logs, send these events to Azure EventGrid. And here I've configured it against my subscription, my resource group. And so now I have in my subscription through EventGrid that Auth0 events, any events, someone typed in the wrong password, someone new signed up, whatever events that are important from Auth0 are now being funneled through EventGrid. That gives me a whole bunch of benefits. And one of them is I can now start to go build other components to respond. So the next place we're going to jump is Azure Logic Apps. These are those event-driven workflows. I've started a workflow here. I've already configured the event trigger. I have it connected to that Auth0 when an event occurs that we showed you a second ago. And now we can start to add in what is the process, what is the workflow that we want to happen whenever a new customer signs up. So one of the things I love about Logic Apps that I cannot do a demo without highlighting is just the number of connectors that it has out of the box. So there's over 300 services here, things like Azure DevOps, Azure Cosmos DB, more recently Azure VMs, so that I could do something like start or stop a virtual machine. But there's hundreds of other services too, whether it's Salesforce, Dynamics, Google Sheets. I'm just looking through, grabbing a few service names that pop. OneDrive, Paylocity, like you name it. If there's a service, SAP on premises, this is all code that I don't have to write now as I'm building this event-driven app. Now, I also have the flexibility though, maybe I do have some code that I want to run. And here I could drop in something like an Azure function direct in this workflow. So here you'll notice the number of work or functions that I have in my subscription because I love functions, but I have one here that will just process that event from Auth0, maybe do some validation, do some string parsing, whatever custom code I need to have happen. So I could go ahead and select this and even pass in some values from that event grid event. Let's pass in the event body. Now, what is this function though behind the scenes? And to show you that, I'm going to switch over here to Visual Studio Code. I could be using Visual Studio as well. This is an Azure function. This is an event-driven piece of code. In my case, the event is anytime I get a request over HTTP. In this case, my Logic app is going to hit it over HTTP, but maybe I'm going to have like a web or a mobile front end hit this HTTP function. And here I could write whatever code I wanted to. I've kept it really simple for the sake of showcasing you here, but I'm pulling out the request body. I'm calling this method process event and then returning back a basic response. So I could write a much more complex function that has a bunch of dependencies doing much more complex code, but I just wanted to give you a feel for that right now. One of the things I love about Azure Functions is that, I've written this event-driven code here. Now I want to test it. I'll go ahead and just press F5 on my keyboard. And what's happening now is that I'm compiling this .NET code, and then it's going to spin up here in just a second the Azure Functions runtime. This is the open source runtime, in this case, running directly on my computer. It's looking at my code, it's looking at the events that I'm interested in, and it's going to give for me a local development environment, the same runtime that will be running when I run this in the cloud, when I run it anywhere. So if this was listening to something like a service bus queue, I could now open that queue and start dropping in events. I mentioned, though, this is listening to HTTP events. So in this case, it said, hey, here's a local endpoint if you want to test this thing out. So I've got this nice VS Code extension called REST Client, where I'm going to do an HTTP request to that endpoint, localhost. It goes ahead, triggers that function. I can now test my code, step through it, everything that I would expect when debugging an app. I get the same experience regardless of language that I'm writing my function in as well. So I write my code, I debug my code, I test my code, it looks good. I can then publish my code. So I can now say, hey, go run this inside of my Azure subscription and only run when this event happens. So actually, I'll show you what that looks like quickly. Here in the Azure portal, this is a function app. For those of you who've used functions before, maybe haven't used it recently, you might notice we have a brand new Azure portal experience to manage your Azure functions. This is super consistent with other Azure resources. So I could come in here and find my functions. Here's that process event function, go into it, monitor it, check the successful executions that might be occurring, whatever I need to do, all from right here in the portal. So that's my function doing a little bit of code that, if you remember, I'm calling from this workflow. Now, I want to show you API management quickly, and that's because it's very likely your organization is using systems, maybe custom in-house systems that aren't yet connectors in this long list that I showed you here. But API management gives me a central spot to manage both my first-party APIs or third-party APIs that I might be calling, all from one spot. What that means is that, hey, when a customer signs up for my startup, maybe I want to interact with other APIs. So here for my startup, you can see I have an asset management API, I have a marketing API, I have a scheduler API. In this case, I want to look at the marketing API. It's discovered, it has a bunch of metadata around it through API management. And I even know, hey, there's a method, you have an API to add a new marketing lead. Sounds just like what I need. And now I get this first-class designer experience for, in this case, my own custom API, but I'm able to click into it right here within the designer and integrating with API management. So I could continue to build this out for the sake of time and because I want to leave plenty of time for questions. You could just hear, this is an example of a workflow I've added, create a record in Dynamics 365 for CRM, post a message to team being like, congrats everyone, we got a customer. I could even come in here quickly and send an email with Outlook, Office 365, and say, hey, thank you so much for signing up. Please buy lots of stuff, spend lots of money because I want my startup to be successful. So you get the idea, right? This really productive environment to build code, workflows, relay these events as I need them here within Azure. All right, so hopefully that gives you a taste of what some of these different tools look like, how you can use them, and more importantly, how you can use them together. But this was just a small taste. I don't have all day with you, unfortunately. So here's a few sessions I would recommend. If you're watching any of this and you're saying, hey, I want to learn more, I want to go deeper, there's a ton of great content at Build this week for you to look into. One that I would call out for a live session is this From Code to Scale session. This is going to be talking about building a specific type of event-driven serverless app, a static web app. So a website that is completely serverless. You only pay when people visit that site. There's some new tools in Azure App Service static web apps that let you do that. And there's a few on-demand sessions as well I'd recommend. I have the URLs here. Hopefully you get them down. I'll stay on this slide for a beat. But one is focusing on event-driven application patterns, specifically about Azure Functions. So it's going to cover deeper some of the patterns we've showcased here, but also talk about things like stateful functions. What if I have functions or processes that I have code that needs to run a little bit longer or do some coordination? There's also a great session around doing event-driven automation. So maybe you're watching this and you're thinking, hey, I could see this applying for doing things like shutting down or updating a bunch of infrastructure that I have running, or managing my resources or my resource groups. I could automate some of the things I'm doing manually by just having an event-driven workflow or an event-driven function kick off in response. Really great scenario, a full 45-minute deep dive on that in this event-based automation session. And maybe you want something even more. Check out Microsoft.com/learn. There are modules like step-by-step guides in building everything that I've shown here today, from functions to event grid and more. Check that out at Microsoft.com/learn. There's probably a module there for you to try out. So with that, we've got about 10 minutes left. Hopefully there's been some questions. And if so, we'll take the rest of the time to answer any questions or go deeper into anything that anyone here might want to learn a little bit more about. So Anthony, I will pass it over to you if there are any questions for us to chat about here for the last few minutes.
Yeah, we have enough questions to last an hour.
Wow, fantastic.
Yeah, so I'll pick out a few. So the first one is, how do you control the scaling of functions so that you don't overwhelm like downstream services like Cosmos DB?
Yeah, this is the downside to that beautiful event-driven scale is sometimes on the other side of the function, you have a SQL database, and maybe it can't handle all of those events and all of that compute slamming it all at once. And so today, the best option you have in our premium SKU, you can set a maximum. There's also ways in this file that every function app has, including the one that I showed you earlier, called the host.json file, where you can control some of the concurrency to help throttle some of that down. But I'll share with you right now, actually, a feature that will be rolling out in the next few weeks. Will let you actually set a maximum scale out across all functions in any plan. So it's not quite here in time for build, but it is coming very quickly. And so keep an eye out on blogs and updates for that feature that will be rolling out in a few weeks that would let you set a maximum across any plan.
Awesome. And this question is probably for Clemens. So I think the question is about a comparison between some of like the more traditional queuing technologies like MSMQ and complex queued components versus some of the cloud services that we have today.
And you're muted, Clemens, by the way.
Sorry.
You're there. Yep.
Yeah, ComPlus, that's my wheelhouse. Yes, so the for MSMQ, the successor technology that we have is Service Bus. So if you're familiar with MSMQ, Service Bus is the technology to look at in Azure, and then queued components of ComPlus The closest we have, and it is actually quite close, is Azure Functions as the components in combination with the service bus trigger that gives you functionality that tracks very, very closely what you have. If you have an existing applications that's built on CompLus and using Qt components, then an Azure function with the service bus trigger will work. And I think in that question, because I also read it, there was also a reference to MSMQ triggers, and that's a very special feature. I don't think that has gotten a lot of love in MSMQ land even, but there the combination is to use a service bus topic with a subscription, and then have that subscription trigger a Azure function, and that's the exact equivalent that you have. So CompLus applications, even though old, if you transfer them up to the cloud with Azure Functions and Service Bus and Eventgrid, you can do a lot of the things that you could do with CompLus, and the code might transfer actually quite cleanly from a conceptual perspective.
Awesome. Thanks, Clemens. We've had quite a few people who are trying to run some stuff in the cloud and some stuff on premises. So I was wondering if, Jeff, you can talk a little bit about how you can tie the two, the cloud and on-premises together.
Yeah, we have a story here. I would say this is even going to be continued focus moving forward. So even before I start answering the question, keep the feedback coming in this area, because this is an area that all of us on this call right now are spending a lot of time making even better moving forward. I would say for now, a few things to note specifically from the function standpoint. And so if I take an Azure function that I want to trigger on, whether it's Eventgrid or Service Bus, I can actually containerize that, bring that event triggering code as well as my code, stick it in a Docker container, and run it anywhere. And so we have a few folks who are using that maybe with IoT devices, where on the edge, they might still have like Eventgrid on the edge, triggering a function in a container completely disconnected from the cloud. Often, though, when folks are looking at this, they don't want just the code running in a single container. They also want some of those scale capabilities. And so this is where we've been doing some investments recently around Kubernetes specifically, and making it so that if you actually have a cluster of compute and you want those different components to be able to scale and run a little bit more like functions run in the cloud, that's where you could start to leverage technology like Kata. I guess I would say for that one, for the sake of time, if you Google or Bing Azure Functions Kubernetes, there's a full document that talks about bringing some of these workloads on premises. So that container concept is universal for both Eventgrid and Functions. But as I mentioned, an API management now also has a container agent that you can run anywhere, but something that to keep that we're going to make even more seamless in the coming months.
All right, so the next question is about monitoring. So with all these kind of app components and queuing technologies deployed, what is the best way to sort of monitor the entire system?
I have an answer for this one. Clemens, is there anything you'd want to add on this one for monitoring from your experience, or I can just take my take on this one?
Go right ahead.
Sure. So the best practice here, I'm going to go for the happy path, is Application Insights has a feature called Dependency or App Map that uses the App Insights dependency features. But one of the nice things that pops up, this is actually a demo I love doing. Let's say you have a function that's triggering on Eventgrid. Maybe it's triggering on a queue or dropping messages in event hubs. And then you have other things that are picking up that message. And at the end of the day, you have a message that might be flowing to a bunch of different functions or components, but they're all a little bit unique. If you're using App Insights, which we integrate with just by default, and you're using things like the Azure Functions triggers, without you having to do anything, you just open up App Insights, you go to the App Map feature, it will actually look at the correlation IDs that we're sending from functions by default, that Service Bus is sending by default. It will look at those correlation IDs and actually help you visualize, hey, here's a single message. I see it failed at step 4 in this process. What happened in step 3, step 2, step 1 that might be completely separate functions? They're all visualized right there so that you get this nice view end to end. Because often, this event-driven, there's downsides to that loosely coupled world, because now you have a bunch of individual things you need to monitor. App Insights is really where I would say hang out there. It's got a lot of really good stuff to help make sense of that loosely coupledness.
All right. So the next question is actually, there's quite a few questions about this. There seems to be a lot of different messaging technologies that we have in Azure, like things like Event Grid, Event Hub, Service Bus, storage queues, and even things like Kafka. This question probably is for Clemens.
Yeah, I'll take this one. Oh, no, I'm just kidding. No, I'm. This is Clemens'
how would you
bread
compare?
and butter.
Like, how would you pick it? How would you pick one?
How would you pick one? So
you have 3 minutes, Clemens.
I know. So I'm trying to. That's exactly what I'm trying to figure out. So for messages, think of commands and events first, and that's a differentiation. So one is trying to make another component do something, and the other one is telling that something happened. Everything we call event hub and event grid is about those events, telling other parties about things that happened. Event grid is for discrete events, which means you have a singular activity, a blob was created, a new lead was created in the CRM system, and you want to go and report this out, use the event grid. If you have a sequence of events that makes sense to evaluate together, like you have a temperature sensor and you want to go and know the average temperature of that and then control an HVAC system, you don't do that on a single read, but you first evaluate, and then based on the average, you're going to go and switch something. For that, you use event hubs. Service bus is for passing commands between different parties, and for those you need to have queue semantics. You need to have queuing, so that you can go and take one party takes that command, executes the command, and then checks that command out of the queue. And so for that, the eventing systems are not ideal. So that's the difference between those things. And then for storage queues, you would use that if you need queuing semantics, but you need to have very, very large queues, or you are an intense user of storage. And then for Kafka, we have the Kafka RPC interface implemented on Event Hub. So if you need to have Kafka in the cloud in Azure, you simply create an Event Hub and then you use your Kafka application with Event Hubs, and you don't need to install Kafka separately or run it expensively on IaaS.
Quite impressive there, Clemens. And I would say, too, before we do our last question, Clemens has actually written some really great content on this, many of which have actually turned into official docs. And so if you want to learn more, there's a blog post from maybe a year or two back now that's honestly one of the best written posts I've ever read on this that goes deeper into what he just alluded to there. I'd encourage you to check that out, too.
Mm-hmm.
All right. So the last question is around Event Grid. So what kind of delivery guarantees do you get with Event Grid?
What we do with Event Grid is if you give us an event, we store that event in a queue. That queue is invisible, but it's triple replicated in a very large cluster. And if any of those machines goes down, then we're going to go and recreate the triple replica. We're going to hold those events for 24 hours. While we're trying to deliver those events. If we act that back to you, we have it safe, and then we will try for 24 hours to deliver that event, and during those 24 hours, that event is safe. If we can't deliver it in 24 hours, then you have the option to configure a destination where we're going to go and drop those events into a dead letter location, so you know that we couldn't deliver those. But during those 24 hours, if your service throws 500 responses or throws too busy responses, we keep those safe. We back off dynamically with the time function, but they're safe. During 24 hours, we give it at least once delivery guarantee.
Perfect. That's awesome. And thank you very much, Clemens, Anthony. It was fantastic having you both on the call. I loved the last 15 minutes as much as the first 15 minutes was a light to give. So hopefully you all enjoyed it as well. If you have other questions too, Anthony, Clemens, myself, we're all on Twitter. We're all available to continue the dialogue elsewhere. We hope you all have a fantastic rest of your week here at Build. We're approaching the final, I guess, 24 hours here pretty soon here. And so enjoy the rest of your week. Thank you all so much, and we will talk with you all again very soon.